collaboration between University of Florence in Italy and Université de Technologie de Compiègne, where I'm belonging. And we try to analyze what is the context of PLM, what this means. Sorry, I should be in front of the microphone. What this means for the originally cosmetic and fragrance industry, and facing to the reality, I will explain that later, we enlarged the study to the pharmaceutical industry too. So, the research question was based, of course, on PLM, as we are in the excellent conference on the topic, and of course, we have several definition, but we prefer to use the Terzi et al. Traditional one, as so many of the colleagues here are remotely contribute to this definition. I think it was more than 10 years ago. Maybe we should work on an update, but anyway, sorry. So, traditionally, we work strongly in PLM for the manufacturing sector, like aeronautics or automotive. And we analyze and assess that what would be or what is the status in other industry, especially chemical process industry, like cosmetics, fragrance, and by an extension to pharmaceutical. So, the first part of the job was a status on what exists on the academic production with a systematic literature review. Then here you have the detail of the research query that we have done for this systematic literature review. And you can see here that cosmetics and fragrance industry is definitely no existing research paper on the topics. There is few papers, but finally it's not academic production, it's more, I should say, technical papers or white papers or blueprint by a consulting company. Then how to deal with our subject, and then at that time we enlarged the systematic literature review to the pharmaceutical one. If you compare what you can have in such a query in the manufacturing industry, it's 10 or 20 more times of papers regarding the same criteria with PLM, PDM, and so on and so on. Then the challenge is to analyze and make some status on where we are. Then first, it has been done with the analysis of the what are the effective keywords used in this sector. For example, PLM in this those sector, it's not exist, and they prefer to talk about new product development or information management, and so on and so on. Another important aspect is the regulatory standards and all the rules existing more in pharmaceutical industry. We have seen during the COVID period when you need to produce a new vaccine in a speed time, but you need approval of the vaccine and so on to avoid big troubles or effects on people. Then, taking account these aspects, we analyze what exists, and the European Commission produced numerous law and regulations that have to be considered in this sector. And for cosmetics and fragrance, it's not so strict like it is in pharmaceutical industry, but there is important rules, because if you put something on your skin, if you become red or blue because of these substances, it can be a trouble. So then we combined systematic literature review with the indirect sources. It was the first status we had. And as a case study, we discussed about how to make some status of the real operation in industry, then we select a number of cosmetics and fragrance companies in France and in Italy, and we carried out some interview. So for structuring the interview, first we need to guide our speaker for how is the process and do they recognize the organization of the pharmaceutical life cycle, for example, and we derive this life cycle for the cosmetics and fragrance industry because nothing exists. It's only an informal organization, and then as these references from pharmaceutical exist, we derived the example and so on for this life cycle. Then there is a important stage on the new product development. Of course, in pharmaceutical or cosmetics industry, it's a formulated product. It's not designing and drawings and so on. It's more a chemical design with the relevant formulation you need. There is a second step with an important work on the patent submission, because if you want to control your manufacturing and the use after the commercial stage, then you need to have patent to be sure that your product will not be chemically reproduced or a wrong product sell on the market with your name, but it is not your product. Then this patent stage is very important in this sector, and of course all the clinical test and review to validate that the product is safe. And after you enter in the manufacturing stage, and last stage is the commercialization and quality management of the product. That is very important, and linked to this quality management there is another aspect. It's pharmacovigilance that analyze if in the use of the product by all people who need, nothing's wrong happen. It's very important to have a mid-term assessment of what is the status of the product and the medicine you may use. So we derived the same assessment with the cosmetic industry, and one aspect is very important is the use of the product information for the safety and compliance depending on the country where you are commercializing the product. Because in US you have the Food and Drugs Administration who validates the product, and in Europe you have some rules, and if you are in Asia, depending of the countries, you have other rules to be compliant. And it's also a very important stage, and as I already mentioned, as you have pharmacovigilance for the medicines, you have the same kind of survey with the cosmetovigilance if you are using some cosmetics and there is some troubles with the use. So we obtain a status on the architecture of the information management. Then there is a strong aspect on the research and development of the product, this first part. Another aspect is the portfolio management. Each time you make some, we would say in software management, a release of the product, because you provide your fragrance in small bottles, then you have the big ones, and you have a shower gel, and so on and so on. Then it's more, you have always the basis the same for the flavor and so on, but the formula is evolving depending on what you are providing to your customer. Then the portfolio management, it's like the configuration management in manufacturing. Finally, it's very important to have clear identification on how to produce and how to distribute also your portfolio. And finally, it's the quality management. It's a classical question we have also in manufacturing. Another aspect is the supply chain, because in cosmetics and fragrance you are on the worldwide market. It's very important. And also to have some management of the geographic variability management. If you have some packaging for the US, it's not necessarily the same for Asia and so on. And then you have some strategy that are very different, and all the regulatory aspects on your product, on the packaging of the product, that should mention some specific aspects regarding the rules and the way of using and so on and so on. So, based on all the status, we have done some interviews from PLM or IT experts or other people that are involved in the product development process or in the manufacturing or in the quality management. And it has been a semi-conducted interview with the list of questions you have here to have a better understanding of what is the status in the this industry sector. And all interview was about 1 hour of discussion. It depends if the expert was very proactive in explaining his job and what is the status of IT-based system in his department and so on and so on. So what I've been for a synthesis on the scientific aspect, as I already mentioned, the systematic literature review provide nothing. Then I assume this paper will be interesting for people of this industry. All the time we discuss with experts, they consider our study is very, very interesting, because there is, I would say, about, we had some 20 interviews, about 10 companies has no PLM and no IT and so on. It was mainly Excel. It's terrible to understand that it's in the way, and after everything is in the ERP. On the half of the company who have some IT that can be considered equivalent or corresponding to a PLM, only a tier has some effective and real PLM. Main one is Siemens. It's surprising because it's not the most agile system to be implemented for another sector than in the manufacturing. And you also have some dedicated solutions like Centric Software, that now belonging to Dassault System. And Lascom is also providing a solution dedicated to a formulated product. So here you have the status of what is the profile of the use of PLM or something like a PLM, and what is the strategy. Then for the company who has already a PLM, in fact they have two strategies. It's fair use and proactive development on PLM. But for many of the interviewed company, finally there is no solution, or they are thinking about that but don't know where they are going. So as a conclusion, all interviews companies state that the diversity of global and worldwide regulatory environment, it's very constraining for them for their new product development, and it's a critical fact. And then PLM would be relevant, definitely. But they really would like to have a unified solution and with a strong interoperability with ERP. But this PLM functionalities still missing. For example, the link with the distribution and sales functionality, the production of regulatory authority documents, with an automated transfer of all required information. And one question still pending, it's the end of life functionality, because currently, except you can bring back your packaging to the shop where you buy your fragrance, nothing is organized. Thank you for your attention, and I will be pleased to answer a few questions before moving to another room for another presentation. Thanks.
Thank you for the interesting presentation.
You're welcome.
At least for me, it's a new word.
Yeah, and you know, Puig is based in Barcelona. It's a big company. We also interview.
Yes,
Yeah.
yes. Any question for Benoit? Rebecca?
Yeah.
I think there is a microphone over there.
Thank you for a very interesting presentation.
Sure.
I have two questions. One on the slide 10, you mentioned there's a knowledge reuse. I would like to know if you can detail a little bit how they reuse the knowledge on that phase. And the second one is, at which level is justified the use of a PLM system in this case? So is it interesting and is it justified the use of a PLM, or another lighter solution would be enough?
Okay, for the first question, the knowledge reuse is finally fairly basics. It's we have they structure all the information about the product formulation and what is also the manufacturing process in the chemical transformation of substances. It's why they call knowledge reuse. And concerning your second question, the PLM is certainly main issue is regarding the regulatory, and regarding the worldwide based market. They need to fulfill the regulatory, and how to have a cross-checking between the products that are manufacturing in several factories around the world and distributed in the correct country, and be sure that all the authorization for delivering on the market are fulfilled, and so on. Thanks.
Any more questions?
I think.
Curiosity, Benoit, before to go.
Yeah.
It seems that on the fragrance industry, the bottle container. No, it was just a curiosity.
Yeah.
Normally in the fragrance industry, the bottle, the containers, and so
Yeah.
are so important, no?
Yeah.
Are not part of the design process. Huh?
Yeah, it's a packaging design, and it's very important for them. And I think that's why Siemens, for example, is used as a PLM in fragrance industry, because originally they arrived on the market via the packaging design. Because the style of the bottle and so on, it's important, like the container it is. Then I think it's
similar to the mechanical.
Yeah. Originally, and then I think Siemens have been hired to advise to transform Team Center for providing a solution for managing the all information about the fragrance or the cosmetics.
I see. Thank you, Benoit.
Thank you. You're welcome. Bye.
Okay. Next presentation, Roland is there. Morning, Roland. You have your, I think it's there. And now our colleague, I think, has the possibility to manage.
Okay, they will manage from there.
I think so.
Okay.
I think he's managing now. Okay, Roland will
My name is Mohammed.
I'm sorry?
My name is Mohammed.
I'm sorry.
I'm the second author of this paper.
Okay, okay. He will speak us about transiting between product development and production, how IT in production development and manufacturing integrate. As far as the presentation is ready. What is your presentation? Is one of these?
I will open it, or they will open
I think so.
Okay.
Okay.
Okay, it's duplicate. Okay. Good morning. My name is Mohammed. I'm second author of this paper, and together with my supervisor, Roland Stolt, we have written this paper in Jönköping University. It's a small university in Sweden, you may know. It's 2 hours from Gothenburg city. So it's about transiting between product development and production. The agenda that I will go through is corresponds to the sections of the paper. I will go through background, literature review, method, and then result and discussion will be followed, and I will conclude at the end. So as a background, this paper lies within concurrent engineering. Its method to run the processes in the design in a parallel form rather than consequently. Examples of this method can be found in enterprise resource planning systems, which are methods to manage all aspects of production, finance, human resource, and etc. And also manufacturing bill of material, which contains all the list of parts and assemblies in a product in a complete form until it's a shippable product. The purpose of this paper, which is also our research question, is to see how this, in this transition in product development and production phase can be done with as low errors as possible and as also as little time as possible. If you consider a development process like this, we have production and we have development phase. There is a point in time where we call that transition time, when we go from development to the production, and we see that in this transition time we have time loss, and also we have a lot of risk for errors. When we look at the literature to see how different PLM literature talks about this transition time, we see 3 trends in the literature. One of them is that systems are integrated into a single environment. Example of this trend can be found in Löwer-Heller in 2014, which they propose a reference model for integrated idea and innovation management in combination with reference processes. The second example is from Rhinos 2021, which they implement a model-based definition and product data management by utilizing capabilities of MBD technology along with the use of PDM software to refine data sharing. The next trend that is clear in the literature is that systems are separate, but data is integrated, and that comes with some KBS or ontology. Example of this trend is from Fisher 2013, which they implement a integrated PLM architecture which provides methods for abstract design of integrated PLM architecture, including semantic and progression. The next example comes from Raza 2011, and it's a knowledge-based, flexible, and integrated PLM at Ford's company, based on innovation in PLM to quickly answer the changing requirements. And the last trend that we see in the literature is that models are extended to incorporate all the necessary information for start of the manufacturing. The example comes for Moons 2015, which he proposed an extended interoperability systematic approach for dynamic manufacturing networks, and also studied the roles and assessments of PLM standards. And also the last example from this trend is Riaz 26, which also proposed a closing loop for extended PLM, which is a trace and track system for physical product after it has been delivered to the user. So a little bit about the method that we have used. This paper is a first explorative attempt in a larger project, and by this we aim to explore a little bit the company practice and also identify the problem areas. 2 sets of interviews has been performed, 11 20-minute interviews with the topic of digitalization in the company and how they practice this has been performed. The interviews has been recorded and transcribed and analyzed by writing a summary, which gave us an understanding of the company's state of practice and level of digitalization in there. Additional interviews, which were informal, were also conducted by company specialists in IT environment, which helped us to refine and validate our findings. The case company is called Thule. It's a relatively large company, 3,000 plus employee worldwide, and they are manufacturing car accessories, roof racks, and all these products that help transportation of the goods and equipments that are large for inside of the car. So it's an automotive industry, and they have roughly €1 billion turnover last year. And also interesting to say that they sell their products directly to the customers. As I said, if you consider a product development in a very basic form, as you see in the black box, there are certain tasks that are happening in the transitions between different stages. For example, from A to C, we see that standardized catalogs, a structure is created on a server, and in this also early stages, we see that the project is not defined yet in the ERP system, and all CAD models and drawings and engineering BOMs structure are handled in the PLM system. And also work processes and versioning also is happening in PLM system. And also there are some other functions that have separate systems. But when we move on to this transition point that we are talking about, and is the subject of our study, we see that there are several manual works needs to be performed. For example, preparation for pre-series production is being carried out. The project documentation is expected to be transferred to ERP system from the PLM system, and FMEAs are approved, all testings are finalized, and financial calculations are also finalized and defined in the ERP system. And also there are some requirement for checking the information in the ERP system. So these are just some of the things that are happening, but actually it looks like this. So different functions in the company needs to transfer a lot of information manually from PLM to ERP, and that brings us to really the problem area of this paper. Because when humans are involved, there are a lot of error, and also it takes a lot of man-hour time to do this. So there must be another way. So I talked about result and discussion together now, but again, if we see that information transit between different gates are not smooth and has high error. Also, we see from interviewing from the other companies, we see it's a relatively general problem. It's not related to our company. It's something many companies are challenged with. And also what's happening right now as a state of practice is that there are checklists that requires this manual input to be checked from different functions. So different units in the company needs to go through these checklists and ensure the data transformation. So what alternative ways exist is that a common database can be developed that transfers the information from PLM to ERP system. This common database is like a extended PLM that includes all the life cycle aspects of a product, and all the application would work toward a common database from which various views can be derived. The second alternative, which we can see that can be a solution for this problem, is that development of different systems are kept the same in a separate form, but they are being integrated via ontology and also some KBS or semantics. And the last alternative is that we use the models that are in production in the development phase as well. So there will be no transfer, but the models will be big and cumbersome, which has its own consequences. So as a conclusion, this study helps us to understand really what the company is being challenged, and also investigate further alternatives for information transfer in the organization. For our company, the way we understand and see is that this gradual integration of the systems and to some extent more homogeneous information model for integrating between different systems is the way to go. The option of a large PLM system is not feasible because of the size of the company, and rather than storing the information on servers in many different and incompatible formats, there should be a common database allowing different views to be derived. And also APIs of different systems can be used to allow each of the application to operate on the common database. Thank you very much for listening. That was all from my side.
you so much, Mohammad,
Yeah.
for the presentation. Any question for Mohammad?
Okay, I may have a question. Because you were talking about like a common database between PLM systems and ERP, but you were not talking about like MPM systems. We have the father who is around, Clément Fortin, who was the father actually of MPM systems. And well, you were saying that we have a problem having those bombs, but actually the one we're using in engineering and the one we are using in manufacturing are different actually, because one is like based on the engineering view and the other one is based on the manufacturing view. So how do you see this common database being able to exist with like different kind of informations?
Sorry, I didn't get the question.
Okay, the question is like if you have like one who is mainly based on engineering view and one which is mainly based on manufacturing view,
Yeah.
there's like a gap between
Yes.
those two bones.
Yeah.
So my question is which form or how could we have like the same database for
Yeah.
engineering view and manufacturing view, which could be different if you don't have this translation from one
Yeah.
to the other?
That's exactly, I think, the first option to integrate these different data sources. And your comment is exactly what's happening right now, because they are different. There's a lot, and they need to be transferred. Information from engineering boom to manufacturing boom needs to be transferred. This causes a lot of issue. And that's exactly brings us to the first alternative, which we need to find a way to integrate. That integration is currently being practiced in literature in different means. Maybe there are software solutions for this, and that's what we are also investigating to see in each of these alternatives how this can be performed. So I guess my answer would be I don't know, but that's exactly the problem, and we are heading toward finding that.
Okay, any more questions? Thank you, Mohammad. Okay, the next presentation, I will present myself because it's a paper that we have writing together with Lucia Recio, Amanda Mariscal, and Estela Peralta. And the name of the paper is A Process-Oriented Approach for Shipbuilding Industry Design Using Advanced PLM Tools. Okay, the paper outlook is, I will make a short introduction, and after I will speak about the complexity of the shipbuilding industry and some special characteristics. I will present the different product and processes structures that play a role on the definition of the vessel. The presentation includes a use case that we have prepared for a piece of a boat, and we propose several product and processes structure to fulfill this approach. And at the end, I will finish with the result and conclusions. Okay, why we'll make this paper? This paper was writing after a collaboration with a shipbuilding industry in Spain, and we discovered that they are really in the first steps of the industry 4.0, and the application of the digitalization tools in the shipbuilding industry is progressive and very slow. And the characteristics of the shipbuilding industry make it different to other, like the car industry or the aerospace. But there are, in the other side, several similitudes, especially with aerospace. That was our field of research. The aim of the paper is to propose several structures, applying our experience on aerospace to try to solve the introduction of these PLM tools on the shipbuilders. Shipbuilders works today in two separate areas. One area is the design office, the other area is the manufacturing. They don't see each other together, and they are in sequential engineering basically. They are not using concurrent tools or collaborative tools, and the idea to have common structures to facilitate this collaborative engineering. Why shipbuilding industry is interesting from the research and industrial interest? This is because, as you can say, the main players that are America, United States, Europe, and Korea, that is one of the main players in the shipbuilding, has scientific initiatives in order to improve the digitalization of this field of industry. Why the shipbuilding industry is complex? There is a lot of different kind of vessels. For every need, there is a different vessel for passengers, ro-ro, tankers, for gas, military vessel, yachts. Every vessel is more or less different to the other. There are not two identical vessels. The manufacturing of a vessel starts when the design is not complete, but not in the term that we know for concurrent engineering. They used to start building the vessel almost when they start the design. It's a labor-intensive industry. It's difficult to automate. The machines that they use are really big and basically manual, and there is a lot of people doing manual work. The accuracy is high, but the structures are also very heavy and very big, very complex, very difficult to manage. The logistics is really important in a shipbuilder, and there is not two vessels with the same configuration. From the manufacturing point of view, is similar to aerospace industry. There is two separate parts of manufacturing. One is the part production and assembly, and the boat is assembly in parts, in blocks, and after there is a final assembly line to assemble all these blocks in a dock. Okay, we define from the beginning the three product structures, the EBOM, or the engineering bill of material, and we say this is a product structure. It's the definition of the product and maintain all the functional definition of the product from the engineering, functional engineering point of view. It's where the definition of the hull lives, is where the mechanical, hydraulical, fuel, electrical, and all the systems are defined. And it's a hierarchical system. The top is the vessel, and there is intermediate levels according to this functional distribution. On the other hand, the manufacturing bill of material is also a product structure. It's a definition of the product and represent the industrial breakdown of the product. Represent what are the part of the boat that you can see on the shipbuilder, on the shop floor. It's the inputs and outputs of the different manufacturing and assembly processes, and also it's an hierarchical system. It's a tree. The top is the vessel, like in the EBOM, is the only point that they have in common, except with the leaves of the structure, and it's composite for all the intermediate products. The third structure that is on the game is the bill of process. The bill of process is a network of process. It's not an hierarchical structure. It's not a product structure. Define the processes and represent the manufacturing and assembly processes based on the EBOM. Why is based on the EBOM? Because the inputs and the outputs represent the different intermediate products that we have in the EBOM. It's a parallelized system because you can have different manufacturing and assembly product running in parallel. And we discovered that was very similar to the aerospace industry, and if we can identify as design and as planning the structure from aerospace to the E-boom and M-boom, we can apply similar techniques. Okay, the use case was a typical boat. It's a typical bulk carrier. It's made using modular construction, different blocks. We have defined in this bulk carrier 7 blocks, and every block is designed taking into account all the systems that contain. In this case, we have concentrated the use case in the block number 200 that is composed, for this simple use case, by the hull that has different shells, the bottom shells, the side shells, the bulkheads, the deck, and also we have drawn a system, a build discharge system that is running along all the boat, but in this particular case, we have a part of the system attached to this block, okay? And this is our use case, and this is where we have built this different product structure that I will present now. Okay, the proposed boom is based on the functional definition of the product. We have the chip on top. We have different levels. The first level we have named system and contains the hull itself, like a system, contains the water draining system, all the systems in the boats that drain water, fresh water or salt water. And in this particular case of our example, one of the water draining system is the build discharge system that is composed for several pipes and joints that is attached to the block number 200. If you can imagine that we have the full structure, we have the full definition of the build discharge system along all the boat just in this box. Okay, that means that we can make all the functional design of the boat just in our product structure. The leaves of the tree are the different cut definition of the parts. Okay. On the other side, the M-boom proposed for this block is this. We have the same level of cut parts because we are based the structure, a boom and M-boom, on the same cut parts, okay? But we make a definition of intermediate products that in this particular case, we make 2 subblocks, subblocks number 201 and subblock number 202, these 2. And also we install in different parts of the shells part of the discharge system to reach finally the block number 200, fully installed to join with the different blocks and produce the chip, okay? In this case, we have the level of the chip, the level of the blocks, subblocks, panels, and the level of cut parts. It's very simple, but just to illustrate how we can combine using the same cut parts, both structure, one fitting the functional requirements, the other one fitting the industrial requirements. The first, okay, this is just to show you how we are using these 2 structures on the boat. You can see on the upper part the M-boom, on the lower part is the E-boom. This is the picture of both structures. This is the shared level. Both structures use the same parts, and the upper level of each one is related to the functional or to the industrial. This is to define the boat. Okay, functional design people works on the boom, industrial design people works on the M-boom, and also produce the bill of process. Bill of process should start with the same parts that we have for the product definition, and will fulfill process by process the different intermediate product defined on the M-boom. every process should have a name, that is what the process perform, should have the different resources that we need to perform the process. I mean machines, I mean space, I mean cranes, I mean human resources, and also the time that is needed. Okay, and the process can be done in parallel. You can see here that these three processes run in parallel, and both three processes produce an intermediate product that is defined on the emboom, and the intermediate process build the subblock 202. Okay, every change that you made on the emboom should be reflected on the process structure in order to maintain the compatibility and synchronize the three structures. Okay, results and conclusions. Okay, we have presented a proposal to build the boat, to build the vessel using product and process structures and to maintain the configuration between the three, giving to every functional engineering, industrial engineering, and process engineering people the same basis to work. Of course, the approach is based on the unique definition of the product. We are using exactly the same definition of the product, and we can maintain the configuration because we can reuse every time that the product change the same product in the three structures. All these CAD parts that you have seen on the are managed through this common shared ledger, and both a boom and emboom structure represent the same product, but from a different point of view. We can apply all these Industry 4.0 and PLM methods and tools to the shipbuilding industry, and we can define the product and the processes in this way. This structure can be maintained in a PDM system and managed by PLM tools. Any commercial software can be used to do that. Any of the popular softwares, Dassault, Siemens, or whatever. The bill of process is fully coordinated with the emboom. That means that every time you see something on the shop floor, you have a digital representation of this subproduct. This is especially important in the shipbuilding industry because you need to move big sub blocks and blocks along the ship, the dock. And of course, things like center of gravity, weight, hoisting points, and all these things are very important. And you have this definition of the industrial product to do that. And the digital continuity is guaranteed with these three structures that works synchronized. Next step should be to extend this to the first part of the product, to the manufacturing and to the erection of the different blocks on the finished vessel, and also to the quality assurance, to the test and trials, and to the delivery. And there is also the need to pass all the three structures to the ERP. This is a similar problem that Mohammed presented before, to have all the manufacturing information in the ERP in order to follow the planning and follow the finance, the number of hours spent, and so on. And that's all. Thank you so much. Any question? Somebody wants to have a question? Manolo?
Thank you for the presentation. How far is the shipbuilding industry from the proposal, and what kind of tools, if they have it, they use to allow co-design?
Shipbuilding industry is, I was surprised when I started to work with them, is really working today in more or less 2D. More or less 2D, except for the whole design that they use some CFD tools, and they are using tools like Rhino and other shaping tools. They don't have functional structure. They don't make the functional design of the product. They never seen the systems, the complete systems. They design the boat and they use the boom as a boom. And they don't make detailed design. They have a lot of drawings, and the product structure that is the boom is used as process structure on the ERP, and the workers perform directly on the dock the different process to fulfill the product using the drawings and experience.
Thank you very much. About 18 years ago, something like this, we had exactly the same work with STX in Saint-Nazaire. And at that time, it was exactly what you described, 2D drawing with 19 levels of the paquebot, you know, and no production management system and so on. At that time, they completely changed their mind in order to improve mostly one point, obviously 3D design, PLM, ERP integration, and so on and so on. But the main issue they really wanted to fight was the number of modification because of lack of integration of information when doing the 2D drawings and so on and so on. So they did not have all these integration of information during the process of elaboration of the ship, which was really a pity, because they had to manage something like 10,000 modifications along the construction of the ship. And the main benefit that they have seen is obviously also an economy of square meters in order to concerning the raw material inventory and so on, because they had some possibility to plan the work and so on. But the most important issue was the drastic reduction of modifications to be managed, because these modifications, the consequence was a loss of money, a lot of money and time. So did you see this requirement, let's say, from the shipyards, and they have this in mind, and what is their position actually? Do they have really also this kind of problem during the elaboration of the ships?
Yes, you are fully right. I know that in France there was the Industry 4.0 revolution on the shipbuilders some years before. My experiences with Spanish, UK, and American shipbuilders that we have working with them, and they are almost in this situation. And exactly the problem for them in production is that there is a lot of modifications. There is a lot of modification due to the lack of 3D design and the lack of DMU management, DMU clash solving, and so. And they discover a lot of problems on production that they need to go back to solve it in design and back to production, and it's like a ping-pong game between them. And yes, was it really identified like you say.
At the beginning, you talked about different ways to build a ship and the need for configuration. Do the data structures you propose and the bombs still contain this variability, or does the configuration happen beforehand and then you build the bomb for a specific variant-free product?
In the shipbuilding industry, it's not on the presentation, also it's not on the paper, but our feeling is that every boat should have an individual boom and boom, and should evolve, because at the end, when you deliver the product, if you deliver the as-built structure, the final structure where you build the boat, you are delivering a digital twin of the boat that can be used for several things. Because if you include on on the product definition, functionalities, and the cinematics, and so you can provide a digital twin of the product. And in my opinion, and to what we are promoting is to have one structure for one boat.
All right, thank you.
Okay. Any more questions? Okay, thank you so much. Thank you. I think now is Sylvain? Yes. Okay, thanks. You have your pen? Good. Let me take the microphone.
Où est-ce qu'on le met? Where I got the pen? Ah, zut.
Oh, maybe you end the presentation.
Yeah.
I don't know where is. Sweep on to maybe the right.
Arrêtez.
Okay, and now start yours. Perfect. Okay, welcome, Sylvain. Sylvain will speak us about a paper about distributed approach for integrated in industrial systems. Thanks, Sylvain.
Hello everyone. So I will be presenting this paper that is a narrative review. So first, we will see the industrial context quickly of this review, then the integration axis in the industry, then the new distributed approach that start to emerge, and then takeaways of the review and future works. So first, you may know the traditional architecture that is the ISA 95, with at the higher level the ERP, then the MES manufacturing execution system, and then at the lower levels, more connected to the machines with the SCADA for the data acquisition, then lower the programmable logic controllers, and then the sensors. So this was from the late 90s, the architectures of the industrial companies. But then lately, as we discuss of Industry 4.0, this very hierarchical architecture is maybe challenged, and we start to propose more distributed and non-hierarchical architectures. So it's in this frame that I will study the integration axis of current industries, and then how it can change with the new Industry 4.0 technologies that are emerging. So what is integration? Integration goal is to improve the overall efficiency by linking its element by means of communication networks, and thereby obtaining a higher responsiveness and effectiveness of the whole system compared with the isolated operation of its component. So really it's to have all the systems with a channel to share the data efficiently and not have humans in the loop to try to close the breaches. So 3 axes of integration that are identified. First, the PLM integration for the product data. So as we know, first the design and the CAO, CAD, then the simulation data, then it goes, as we've seen before, in the bill of material, engineering bill of material, and the manufacturing bill of material. Still, this is quite only beginning of life, and then the rest of the life of the product, really there is no integration of the data. Then for vertical integration and horizontal integration, an update of the ISA 95 of the automation pyramid. Then for the vertical integration, it would be at each level. So in this new proposal, the ERP still is the higher level that is called here company level. Then the MES is the cell level, and we have put together all the machines in one level that is field level, and it's more an industrial perspective because the industrial use the machines with an interface without going more in the details of the data. So in this frame, the vertical integration would be the integration of the data between all the levels. So first ERP, then MES, and then the machines. As MES and ERP are softwares, they are IP-based, and so there is no interoperability issue. Maybe semantic issues, but the IP-based network is mainly working. And then where there is a real challenge, it's for the interface between the cell level and the field level, because it's not IP-based network, it's more, as some says, there is the IT for the upper layer and the OT, operational technology, for the lower layer, where we still have many challenges to solve, to have a functioning integration. So this is for the vertical integration. And then for the horizontal, that would be the integration of the systems at the same level. So quite easy for the upper level, because there is usually only one ERP in the company, only one MES. But then for the field level, here again there is a challenge because there are many machines that are not communicating together, and usually we try to have that through a vertical integration, and then hierarchy and only vertical communication. So this was the current architectures we find in the industries, but we have since 2015 new architecture model. So I will present one here. That is the RAMI 4.0, Reference Architecture Model Industry 4.0. So here we can find on the bottom for you, bottom right, the same level as ISA 95, so enterprise, work center, station, control device. But then we have more dimensions. So on the bottom, bottom right, the PLM life cycle value stream. So for the type and for the instance. And lastly, vertically, new business layers. So as we see, this is much more complex than the ISA 95, much more complex, but it could then allow architecture that are not so vertical and hierarchical. So what actual development we can have of these new architectures? So there are multi-agent architectures that I will present here. So cyber-physical production systems that are composed, so we can imagine a machine as a cyber-physical system, so that has a physical system, for instance, machining, or logistic that can move things. Then the cyber part that can compute. And lastly, the access to the network and the ability to communicate with other, and for instance, with other cyber-physical systems. So we can imagine an architecture with a network of cyber-physical systems. Then we also have product-driven systems. Here, it would be the product that bears the information and share it to the machine when it arrives. So not a vertical data coming from the ERP MES, but directly the product handling his own data. And lastly, manufacturing service bus, that would be an extension of service-oriented architecture that we use for softwares. But they're including, so the software part, but including also the machines. So theoretically it would be interesting, but as it's very software, we don't really have suppliers to think of extending that to at an industrial scale to companies. So the main takeaways of this review would first be that distributed approach are not yet mature, as we see how deep the ISA 95 is deployed in the industry. But as it's not so hierarchical, it could react more quickly to incidents. So instead of calculating again all the schedule at the ERP level, locally, machines could take decisions way faster and maybe also smarter. Then also the interoperability question we've seen it's now focused on the IT-OT interface. So between machines and IT, and the interface in this case would be the MES. And lastly, ISA 95 does not really include PLM data. So the new distributed approaches, such as product-driven systems, they could handle both the product data and the OM, the operation management data, at once, and so have a deeper integration. So now for the future works after this paper, so as I said, MES is the manufacturing execution system, is the key node between IT and OT for a smooth transition from traditional architecture to the Industry 4.0, and it is largely deployed in we start to deploy it in the industry at scale, so it could be the opportunity to, at this level, connect, realize, make the Industry 4.0 with a mixed approach between the vertical and the horizontal approach. So in the lab, I intend to connect an MES to the automated line we have, and then go further with a review of a systematic review for MES and OT interfaces. Thank you.
Thank you, Sylvain. Any question?
Thank you for your presentation. You propose some takeaways, but in fact, if I am a company who would like to get maybe more benefit about or conclusions concerning distributed approaches, what could be your maybe 2 or 3 main advices concerning, I don't know, configuration, maybe collaboration, or technical issues, or even competencies, or what are the key issues that you would like to advise?
Yeah, that's a good point. One thing is, I think, as I'm quite new in the field, I see that the ISA 95 and the vertical integration not only has a great influence on the architecture we have now, but also on the way the industrial want to steer the industrial systems. And there, I mean, they want the control, they want centralized control, and maybe if we advance in the, so I mean on the long term, if we advance on the algorithm and the way to automate decisions, maybe we could challenge that really. And if the industrial doesn't think it can be more efficient to lower the point where we take decisions, then they won't want to change. So maybe I think we could try to challenge, and any paper or use cases where we see lower level decisions having good influence on the performance and on the incident management, I think that this would really help to push in this direction.
Okay. And concerning the scientific side, did you see after this study some inspiring topics to be proposed in order to extend some scientific fundamentals, or do you see any lacks, fundamental lacks that could be more digged in depth or investigated in depth?
Yeah, precisely on this topic, there is mixed systems where you have both centralized and local decisions, and then the algorithm to decide when we have centralized decisions or decentralized. And so I've seen some papers on that topic, and I think there is a lot to improve there, but this would, I mean, be fundamental advances. However, my scope, as it's also an initial PhD I'm working on, is to actually integrate things at scale and reliable proposals.
Okay, so see you next year for news about your work. Thank you very much.
Thank you.
Any more questions? We have time, because we are 10 minutes in advance. No, I have a question for you before you leave. You mentioned that interoperability is. You mentioned that interoperability was IT/OT issue or problem, or in charge of IT/OT. Can you explain what you do understand about that? What interoperability between systems is just an IT, or what is about the definition of the data model, or?
Yeah, so for interoperability, there is, I mean, a first level of interoperability that is technical interoperability. So can we actually connect systems together? And then higher levels of interoperability that are semantic interoperability, where we understand and both systems understand the data and in the same way. So for the IT/OT interface, we still have technical interoperability issues in the sense that in the industry, with legacy systems that are quite old, we may not be able to connect all of them to the systems. But then if we now only discuss of the current technologies with platform, standards such as OPC-UA or MQTT, then this also bear data models. So with new technologies, the interoperability issue is mainly semantic. So to understand the data, that can, as we have technical interoperability, then the higher level would be to understand the data. But then the scope, one other problem is that when we have a lot of data, and the scope is really huge, such as for an industrial company from the ERP to the machines, then the data model, the semantic interoperability, would be huge. So then how to manage and how to deploy at this scale the semantic interoperability, this is also a current topic.
Okay, thank you so much.
Thank you.
Okay, thank you to everyone to be on the session. We have finished 10 minutes in advance. Now we have a break of a half an hour. You can take a coffee. Don't forget that 11:30 is the closing session, okay? Here in this room. Thank you so much.